Hey everybody, this is Brian. If you're watching, this is our fourth video in the Java series, and as promised, we're going to be covering a little bit more about classes and what happens behind the scenes here. So as you see, we've got our project with our source folder, our default package. Remember, anything that you don't define a package goes into the default package. There's start.java. This is our actual code file, and if you expand this out, you can see that we've got start, which is the name of the class. See the big C there, and then main. That's a method. So there's start and main. Now, public is an access modifier. You can have public, private, protected. That determines who can see what. We'll be covering access modifiers later, but just know that you need an access modifier. You need to tell it who can see this. So, because this is the beginning of our program, we want everyone to see it. Class just says that this is a class. Now, the typical structure of a class looks something like this. Class, name, bracket, and bracket. You don't always need an access modifier. I kind of lied to you. I know. I'm sorry. I try not to do that. But in Java, you need an access modifier for your class instance. In a file, start.java is the name of the file, you must have a class called start. You cannot have start.java and call it kitty. Java won't like that. Let's do public. You see it's already complaining. It's saying the public type kitty must be defined in its own file. Now we can get rid of this access modifier, and this is allowed because this is not a public class. This is a default class. So start is in its own file, and we can have default classes in there. Default is just an access modifier. Now these brackets denote the start and stop of a code block. That is a code block. Anything in here is code that will be executed inside the kitty class. Now we have methods. Methods being like this public static void main. If you've been with other languages like C++ or C# or even Visual Basic, you'll kind of know what a method is. It's similar to a subroutine in Visual Basic. And you will say public, whoops, void test. You see the structure is similar. We have an access modifier. You can even take the access modifier away and give it the default access modifier. Void means it's not going to return any data. It's a return type. Test is the name. Let me pause this for a minute, guys. The cat's begging for my attention. Sorry about that. Now that I'm cat-free, we can continue. Alright, where were we? Oh, yeah. The void means it will not return anything. You must always return something or tell it explicitly you're not going to return anything from a method. Test is just the name. And then your argument list. We're not going to have any arguments, so this is just brackets, and then your code block. Now, you can also have arguments in here. It's like we will say int x. So x would be an argument of an int type or integer. We'll go over variables, another one. Just once again showing you the basic structure. That's one of my pet peeves about Java, is it's kind of difficult to jump right in because you have to understand the framework and how everything glues together before you can actually start working in it, but you have to work in it to understand it. It's kind of a chicken or the egg scenario. That's why it's helpful if you know another language before you jump into Java, even though most colleges are starting to teach Java as a beginner course. So let's just delete our kitty class. Sorry, kitty, you just got deleted. These are comments, and these are comments. What's the difference here? Well, this is what's called a Java doc comment. The /*. Whenever you do something like that, let's just do /*, and you hit enter, and you see it automatically adds author. This is a Java doc. You can run a program called, ironically, Java doc, and it documents your classes for you. And it'll go through and pick out certain keywords like author or parameter. And it'll tell you, okay, the author of this is, Brian Cairns. The parameters are the args. This is also a comment. A comment Just 2 lines, or whack whack as people call it. And then whatever stuff you want to put in there. The compiler will not compile that. You see how it's kind of complaining because this has got spell checking integrated into it. Pretty nice, huh? So we'll just say test, and then system out print line hello world. Well, what are we doing here? Well, system, this is the Java lang system. This is a package that you are importing automatically. Remember, we were talking about packages, and we're calling the out class, and then we're calling the method print line, which prints a line into the console, and the parameters we are giving it is a string of hello world. Now, let's discuss for a minute public static void main, because I know you're looking at this thing going, what in the world is that? That is a holdover from the old C, C++ days. The beginning of a program needs to have this thing called the main method, or the main function. That's how the compiler, or the executor, knows where your program starts. It looks for the instance of the main program. Some languages can only have one main method for the entire program. In Java, you can have a main per class, so your program can start in any class. It's very helpful for debugging situations. Now that we've kind of gone through the structure of a class, what's going on behind the scenes here? You remember start application, and then it's calling C program files, Java W. What's going on? Well, the compiler, or Java C, is actually grabbing the source file start.java and compiling it into a class file. And what is that? If you go into your workspace here, you see there's metadata. This is added by Eclipse, and there's test. This is our project. You got .settings, once again added by Eclipse. You can see org, Eclipse, etc., etc. And then there's bin, source, and then some more little files in here. In bin, which is short for binary, you have start.class. What is this? We didn't make this. We made start.java. The compiler compiles your Java files into class files that the runtime environment then executes. Alright, let's go back over that. That was a little confusing. In the source folder, you have start.java. This is our Java file. The same thing we see in Eclipse. In the bin folder, you have a class file. This is what the compiler creates. Now, if we try to open this, let's select program from list. Where's handy notepad here? Notepad. You see a bunch of weird garbage. Let's word wrap this. What is this? This doesn't look like anything that we typed. Well, this is our class file. It's been compiled by the compiler. What happens is Java takes your Java files, compiles them into a platform independent neutral language, and then the runtime environment executes those. So when you distribute your program, you're not distributing the source code, you're distributing the class file. Now you can actually go back into the source, and let's just select program from list, notepad, whoops, notepad, and you see there's your source code. Nice, safe, and sound. Now, just so you know, this is not 100% secure, this class. People can use a decompiler. I think a popular one is JAD, or JAD, Java Application Decompiler, and they can actually decompile your class file back into the original source code. Highly illegal, highly controversial, but I just want you to know it is possible. People do it. And other languages are not immune. Even, C++, C#, Visual Basic, all those languages can be decompiled. It's called reverse engineering, something we'll probably cover a year or two from now when I start going over the hacker tutorials. Alright, anyways, that's a totally different subject altogether. Today you should be a little more familiar with classes and what they are, the structure of a class, why we need this main method, and how to print something out into the console. Thank you for watching. I hope you found this video educational and entertaining, and as I said, I'm going after the Sun Certified Java Programmer certification, so expect to see a lot more of these.